Hello friends, once again welcome to our this new video. This is the video number 17 based on the chapter solutions. In this video we are going to learn the two important relationships. So that is all, the relationship between the osmotic pressure and concentration of the solutions, and second one, how to determine the molar mass of the solute from the osmotic pressure. So see, these are the very simple mathematical equations or relationships. See, first of all, the osmotic pressure and concentration of solution. So how the osmotic pressure, that is pi, is related to the concentration of the solution. For very dilute solutions, osmotic pressure follow the following equation, this one, see here. For the dilute solutions or very dilute solutions, the pi, that is osmotic pressure, so this is equal to N2 RT upon V, that is all. See here, what is the relationship between the osmotic pressure, pi, so this is how related to this, see here, N2 RT upon V, where V is the volume of the solution in decimeters cube or in liters. V is the volume of the solution in decimeters cube or liter. N2 represent the number of moles, that is what, moles of or number of moles of the non-volatile solute, number of moles which are present in this V, decimeters cube of volume, that is the N2, and R is the gas constant. So gas constant, which is given in 0.08206 decimeters cube into atmosphere per Kelvin per mole, like that. We know gas constant R 8.314 joules per Kelvin. So in this case, this is given in decimeters cube into atmosphere per Kelvin per mole. That's why gas constant is equal to 0.08206 decimeters cube into atmosphere per Kelvin per mole. So that is what. See, a very simple relationship, how pi related to this or related to the concentration, that is N2 RT upon V. See here. So we know here N2 upon V. What is this N2 upon V? That is the concentration. Number of moles per unit volume, number of moles per liter. Is it right? So that is what N2 upon V is equal to concentration in terms of molarity. That is what the concentration which is expressed in terms of molarity. So what is the molarity? That is the number of moles per liter of volume or number of moles present in V liter decimeters cube of volume, and that's why this can be denoted by the symbol capital M, molarity. So here pi is equal to what? MRT. So this is the relationship. How the osmotic pressure is related to the concentration. The capital M stands for the molarity, that is the concentration in terms of, that is molarity, in terms of molarity. So in this way, how the osmotic pressure is related to the concentration. So this formulae we have to use at the time of solving the numericals. So simple such type of relation is there. See here, furthermore, how the molar mass of solute can be determined by using the osmotic pressure. So in this case we have seen at the beginning. So all these colligative properties are useful to determine the molar masses of solutes dissolved in the given solution. So similarly, the osmotic pressure is also useful to determine the molar mass of solute. So how this can be done now? See here. If mass of solute in V liters of solution is W2. Now see, instead of number of moles per liter volume N2 by V, instead of this we know that how the number of moles can be calculated when the weight is given there. How the number of moles calculated? That is the weight of the substance W2 divided by its molar mass, that gives the number of moles. So very simple. If mass of solute in V liters of solution is W2 and its molar mass is M2, then number of moles W2 upon M2. So we have already studied this simple formula, how the number of moles can be determined. So here W2 stands for the weight or mass of solute. Weight or mass of solute divided by M2, that is the molar mass of the solute. So in this way, the number of moles, that is N2, can be determined by using this formula. And now by substituting this value of N2 in the above formula, we will get simple relationship. Look at this. Pi is equal to W2 into RT upon M2 into V. That is what? Instead of N2, we can write W2 upon M2. That. And just then, now see here, we will get this relationship, how the osmotic pressure is related to this. And then here, M2, that is what? By rearranging this formula, molar mass, that is M2, can be calculated like this. M2 is equal to what then? W2 RT upon pi. So we have to remember this formula. We know the meaning of all these terms. W2, weight of the solute in grams. R is the gas constant. Its value is given there. When the V is in the decimeters cube, at that time the gas constant 0.08206 decimeters cube into atmosphere per Kelvin per mole. Temperature in Kelvin. Is it right? Pi is the osmotic pressure. So these are the two simple relations. That is what? How the osmotic pressure is related to the concentration of the solution, and second one, how the molar mass, that is the application of osmotic pressure, how the molar mass of solute can be determined. So we have to remember all these three formulas, and we have to use these formulas at the time of solving the numericals. So in this case, one more important thing we have to note here, that is what? The concentration of the solution or concentration of the solute in the solution, that is what is expressed in terms of molarity. This is because the molarity is the temperature dependent quantity. We know molarity is the temperature dependent term, and that's why similarly the osmotic pressure is also measured at the constant temperature. That is what? Osmotic pressure is also measured at the constant temperature, and that's why instead of molality, the concentration is expressed in terms of molarity. That is one aspect we have to remember here. And then we will try to solve the few numericals which are given in the textbook by using these two formulas. Let us see this numerical based on determination of molar mass of solute with the help of the osmotic pressure. So this is the numerical which is given in the textbook. So I have tried to solve it with the help of log table. So look at this. First of all, read the numerical carefully. What is the molar mass of a solute if a solution prepared by dissolving 0.822 grams of it in 300 millidecimeters cube or milliliters of water has an osmotic pressure of 149 mmHg at 298 Kelvin. So that is what the mass of or weight of solute is given there, which is dissolved in this much solvent, that is water. Then we have to determine the molar mass of solute. The osmotic pressure is also given there. So from this it is observed that this numerical is based on this formula, that is M2 is equal to W2 RT upon pi V. So how to solve this? So first of all, write down the given data. So what is given? Weight of solute is given, W2 is given 0.822 grams. Then we know the value of R, 0.08206 decimeters cube into atmosphere per Kelvin per mole. The temperature is given there, T is equal to 298 Kelvin. Then osmotic pressure is given, 149 mmHg. So we have one conversion. So that is what? The osmotic pressure is given in mmHg. How this can be converted into atmosphere? See here, 760 mmHg corresponds to 1 atmosphere. So 149 mmHg corresponds to what? So by cross multiplication, we will get 149 into 1 upon 760. So that is what 149 upon 760. So this can be solved with the help of the log table. So we know, so log of 149 minus log of 760. So I have written here, look at this. So by taking the logs of this, the characteristic of 149 is 1.4. The log of 1.4 in 9 gives this value 1732. Similarly, characteristic is 2 here. So log of 7.6 into 0. So 2.8808. That is what, by subtracting this we will get bar 1 2924. That is what. So simple subtraction is there. Then by seeing the antilog of this we will get 0.1961 atmosphere. That is the conversion, how the osmotic pressure is converted into the atmosphere. Then the V is given, volume of the solution is given. That is what, look at this, 300 ml milliliter. So milliliter or millidecimeters cube, we have to convert this is also into decimeters cube. We know the volume, the unit for the volume is decimeters cube. So that's why, look at this, this can be converted 0.3 decimeters cube. Now just substitute all these values in the above formula. So value of W2 0.822 into value of R 0.08206 and the Kelvin temperature 298 divided by, that is the value of pi 0.1961 in atmosphere into the volume, that is what, 0.3 decimeters cube. Then I have converted this in the form of powers. So this can be written 8.22 into 10 to the power minus 1. Similarly, this can be written 8.206 into 10 to the power minus 2. This can be written 2.98 into 10 to the power 2. Similarly, 0.1961, this can be written 10 to the power minus 1 here. And similarly, 3 into 10 to the power minus 1. Now look at this. This can be written like this. Minus 2 plus 2, 0, this minus 1, 10 to the power minus 1, and at the denominator 10 to the power minus 1, 10 to the power minus 1, that is 10 to the power minus 2. By taking this above, we will get plus 10 minus 2 get converted into plus 2, 10 to the power minus 1, that is 10 to the power 1. So keep this besides and try to solve this with the help of log table. I have solved this here. So simple one, just see the values of log. So 8.22 characteristic 0, value of 8.2 into 9143. Similarly, characteristic 0, 8.2, log of 8.2 in 0, and mean difference in 6, 0.9141. Similarly, 2.98, like that. See here, 4742. The log of 2.98, like this. By addition of this, we will get this value. Again, see the antilog. So we will get this answer of this is like this. Then similarly, the terms which are present at the denominator, solve this. 1.961, the log of this is like this, 0.2925, log of 3 like this, 0.4771. So by addition we will get 0.7696, antilog of this is 5.883. Divide now this, that is the term which is present at the numerator by the denominator term. So this is solved with the help of log. Look at this, log of 201.2, this minus log of 5.883. By placing the values, log values, we will get 2.3036 minus 0.7696. The answer is like this, 1.5340. So here, as look at this, the antilog of this, we have to see the antilog of this. So 5.53 antilog of into 4 and difference 0. So we will get 4.20 like this, and this 10 to the power 1 is there, so that's why 342. So final answer is 342 grams per mole. So in this way, so you can solve this numerical with the help of log. So this much practice is not enough, much more practice is required. So at the home, try to solve such type of numerical with the help of log table. And this is very important, determination of the molecular mass of a solute with the help of osmotic pressure. So thank you. We stop here.